We're moving on in calculus in chapter 4, which is extreme values unit. This is going over section 4.3 and 4.4 of the calculus of first course textbook, explaining the first derivatives and how to find extreme values, especially when it has some word problems. So the first part in 4.3, it's using the first derivative. And I just have here, simply put, you're using a function, take the first derivative. If there is a sign change to your slope, you're going to have a maximum or a minimum. So if it goes from a negative slope to a positive slope, that shows you'll have a minimum. And if it goes from a positive slope to a negative slope, that shows you will have a maximum. Just have that. And if there's no change in the slope, then there is no max or min. So looking at the homework on page 182 and just picking a few questions from each section. The first one, finding the max or mins of the following. So again, anytime with that, you want to look at the derivatives. So take the first derivative and you'll get 6x minus 4. And then you just want to factor out a 2. If you take out a 2, you'll have 3x minus 2. Now that we have this, that means that you have your critical number of 2 over 3 if we set our factor equal to 0. And if we do look at a number line, which I do think and highly recommend is the easiest way to look at these problems, you have your number 2. That more matters if it was negative, and you have your factor 3x minus 2. So the value of 2 is always positive, so we're happy with that. The 2 over 3, that is when our slope would be equal to 0. And then if you have a value less than 2 over 3, and we were looking at the factor 3x minus 2, your slope would be negative. It's a little bit delayed there. If we had it over 2 over 3, your slope would be positive. So remember, with the first derivative, we are talking about our slope. So then if you take a look, a positive times a negative will be a negative, and a positive times a positive will be a positive. So I should actually do this. Show it's a negative, show it's a positive. So that means that the value 2 over 3 is a min. And then if we wanted to know what y equals at that point, you just plug it back into your first equation. So find f of 2 over 3. F of 2 over 3. Plug it in for x all the way through that first f of x equation. And we'll leave this as a fraction. You get 35 over 3. So the next one, similar idea, just doing the same thing. This was actually the letter D from the textbook. F of x, we want a max or min. So anytime you're looking at a max or min, you are looking at the first derivative. And if I go ahead and solve for that, that's going to be 4x cubed minus 3x squared. And then from each of our terms, you can take out an x squared, and you're left with 4x minus 3. Setting each factor equal to 0, your critical numbers are 0 and positive 3 over 4. So again, that should be a 4. Looking at your number line, we're going to plug that in. You'll have the value 0, and we have the value 3 over 4, and we have numbers bigger than that. So looking at x squared, doesn't matter what you put in, it will always be positive once you square it. When we look at the value 4x minus 3, anything less than 0 will be negative, between 0 and 3 over 4 will be negative, and above it will be positive. So when we look at our slope, here we have negative, negative, and then our last one we have positive. So we know at these points it's just 0. So this tells us that we do have a minimum, a local min, and that happens when x is 3 over 4. So just like the previous question, if we know that, then we can figure out what y equals by plugging it back into the original equation and solving for y. Moving on to question number 2, this one's asking for the critical numbers and intervals of increase or decrease, and then a local max of the function. And I think this also says local min if there was one. So let's take a look at this first one. So same idea, if you want a critical number or intervals of increase or decrease, you need the first derivative. So finding that first derivative, you would have 6 minus 12x, factor out of 6, and you have 1 minus 2x. So your critical number is going to be setting that factor in equal to 0 and finding that x equals 1/2. So when we're looking at our chart, once again, we will have 1/2 is our only critical number. When we look at our factors, you do have the number 6. Again, we're going to write that down for habit. Again, it matters more if it was negative. And you have the other factor of 1 minus 2x. And then we're looking at our slope. So that first one, x is always positive. At 1/2, your slope is 0. 1 minus 2x is negative if it's a lower than 1/2, and positive if it's higher. So looking at our slope is negative and then positive. So that tells us you have a minimum at the point 1/2. It also tells you anything lower than 1/2, you're going to have a decrease. Anything larger than 1/2, you'll have an increase. And that was our local, in this case, minimum, not maximum. Our next one, same idea, doing that same thing. And, oh, this one needed me to graph. So just graphing that really quickly. I just probably graph my point for 1/2. And though it's up here somewhere. And then it's opening downwards. Okay, so our next one, again, finding your first derivative. We have 12x to the power 3 minus, what do we have there? 48x squared plus 36x. We can take out a 12x from each term, and you have x squared minus 4x plus 3. And then lastly, factor a little bit further, and you will have x minus 3 times x minus 1. Now from here, we'll look at each of our factors. So our critical numbers are going to be 0 from this one here. It will be 3 and it will be 1. So making our number line, and this is going to get a little squished, we have 0, we have 1, and we have 3. And then our factors, you have 12x, x minus 3, x minus 1, and we want to know what's happening with our slope. So for 12x, anything less than 0 will be negative, between 0 and 1 will be positive, and then it just gets positive the rest of the way. And again, reminder, at those critical numbers, it will be 0. And then for x minus 3, anything less than 3 will be negative, greater than 3 will be positive. And so x minus 1, anything less than 1 will be negative, and then will be positive. So looking at our slope, we have, for that first section, it will be negative, and then it's positive, then it's negative, and then it's positive. So we have a local min at the point 0, we have a local max at the point 1, and then we have another local min at the point 0. So we can go figure out what those points are and do a very quick sketch of our graph, and it ends up looking something like that. But we could do that a lot better if we did have some graph paper, but this is just, again, a quick sketch. If you look at question number 3 of your book, and this is 3C, all of question 3 is very, very similar, except like it's listed there, the math is just a little bit harder. So for instance, if I am finding, and in this one you still want to find your local min or your local max, we would still be doing the same thing. So I would still want to find f prime of x. I'm going to rewrite this before I start as x times 4 minus x to the power of a half. And then keep going from here. If I am finding f prime, why this is harder, now we're using more rules. So we would have to use the product rule here. So we would take our starting value x and multiply it by the derivative of the second term. So we're going to multiply this by a half, and then times 4 minus x times, or now subtract 1 is negative a half. Add on your second term, which was 4 minus x. 1 second here. Oh yeah, we would have had from the inside here a negative 1 times negative 1, just using that chain rule. So 4 minus x to the power of a half times the derivative of x, which is just 1. Now we're going to keep going from here, and from here you would be able to factor out a 4 minus x, and you always want to take out the smallest amount, and that would be 4 minus x to the negative a half. And when you do that, you're left with negative x over 2 plus 4 minus x. And before I move on, I'm just going to simplify what's in these squared brackets. I'm going to multiply each term by 2, and that will get me negative x plus 8 minus 2x all over 2. And simplify a little further, you have 8 minus 3x all over 2. So if I replace this where my squared brackets were and multiply through and simplify, I would end up with 8 minus 3x in the numerator and 2 times root 4 minus x in the denominator. So that's my derivative. Then I want to set each of my factors equal to 0. I would say my critical numbers here, what makes everything 0, would be 8 over 3, and it would also be 4. So moving on from here, just looking now at our number line once again, you would have 8 over 3 as one of your values that would give you 0 for the slope, and you would have the number 4 as one of your values that would give you 0 for the slope. And then our factors, you have 8 minus 3x, and you have the root of 4 minus x. So looking at the first one, anything less than 8 over 3, your slope will be positive. Anything above that will be negative. For the value of 4, if we plug in anything below 4, it's going to be positive. And then if you plug in anything above 4, that would make what's under the radical negative, and that's not possible. So in terms of our math, this will not exist for x values above 4. So with that, you do have, looking at your slope, we have a positive slope to start, then we have a negative slope. So we do have a max right here at 8 over 3. Just looking at 2 more from chapter 3. I like question number 5 with the graphing. I like question number 5 with the graphing. I think I took off one other one. So question 5 with the graphing, we're just going to start with a quick little graph here, and they're giving us some points. So I know this isn't the best, but when x is 2, we have y equaling 3, and when x is 5, we have y equaling 6. So we can plot those 2 points. Then it tells you f prime of 2, so looking at the derivative at 2 is going to equal 0, meaning the slope will be horizontal, and f prime of 5, the slope is going to be horizontal. So that's implying that those points are either a max or a min. Then if it's telling you f prime of x is greater than 0, meaning a positive slope, when x values are less than 5, that means we're going in the positive direction until we hit 5. Then anything less or greater than 5, you're going to have a negative slope. Once we get to that value, then it's going to go into the downward position. So that's our very quick graph. My tablet's just catching up to me here. Maybe not. There we go. Going in the downward position. Okay, so that's all of section 4.3. And the next part is 4.4. I like that this is not right there. 4.4, and that is applying max and min to word problems. So this is a little tidbit in your textbook that says what you need to do is understand the problem, draw a diagram if you need to, introduce some notation, and then this is the really big part here. When a max or min is given, that means the derivative at that point is equal to 0. So I'm just looking at the first couple questions on page 188 just to start setting up some of these problems. So for this one, saying find 2 numbers whose difference is 150 and whose product is a minimum. So that means when we multiply them, it's going to equal 0. So looking at this, we need to assign some variables. So we can say let x equal the first number. Sorry, my phone was just ringing. And we'll let y equal the second number. Okay, so one of our equations will be x minus y equals 150. The other one of our equations will be for the product. that your product, which will matter in a second, will still be x times y, because product means we're multiplying. Okay, so we do want to write one in terms of the other, so we can rearrange the first equation to get y alone. So we can move x to the other side, divide by a negative, and we'll find out that y equals x minus 150. So the reasons why we're doing this is we want everything to be in one variable. So now that I know what y is, I can plug it in to my product. So my product now can be x times x minus 150. We can expand that out. We'll get x squared minus 150x. And then that part where it says that this product is a minimum, that means if we take the derivative of what's happening, we would get 2x minus 150. That would equal 0, right? Because if you have a product or anything equaling a minimum or maximum, that means your derivative equals 0. So if it equals 0, that now means we can solve for x. So if we went 2x minus 150 equals 0, solving for x, x is going to equal 75. Okay. Now, we could still do our sign chart, show that that's going to be a minimum, but it will be, and that means if x is 75, then y would have to equal negative 75. Oh, not 175. Negative 75 to make this equation work. Our next one is one with a rectangle having a perimeter of 100 centimeters. What's the length and width should it have so that its area is a maximum? So again, if we have a max or min, that means we can take the derivative of the area and set it equal to 0. But we do need some variables here. So perimeter for a rectangle would be 2 times the length plus 2 times the width equals 100. We know that the area will equal length times width. Now again, we don't want two variables going on, so we'll write one in terms of the other. So it could be either. I just had with L. If you isolate L from that first equation with perimeter, you would have 100 minus 2w divided by 2. And we can simplify that a little further, and this would be 50 minus w. So now that we know length in another way, we can plug it back in to that second equation. So our area will equal that 50 minus w times w. We can expand this out. We'll have 50w minus w squared. And now going back to the point where it tells us that the area is a maximum. So let's take that derivative of area, which is going to be 50 minus 2w. And if it's a maximum, you can set it equal to 0. And then solve for w. When you do, you'll find out that w equals 25. And then when you go back and plug it in for w and solve for length, you'll get that your length is also 25. Oh, that got messy. Your length. So that is our very quick snapshot. Then there's more, but that's essentially what you have to do. If it gives you a max or min, take that derivative and set it equal to 0. If you did find this helpful, please subscribe. And if there's any other video I could ever do for you, let me know. And you'll be continuing with these calculus videos as I go back through the curriculum. Thank you for watching.